Good morning, students. Today we are going to see introduction of radiation and its properties. It's unit 1 of radiation application and safety. Let us begin. Introduction. Radiation is a natural phenomena involving energy transfer from through waves or particles. It comes in two types. First is ionization radiation and second is non-ionization radiation. In under ionization radiations, X-rays and gamma rays comes under this type, and radio waves, visible light, it comes under non-ionizing radiation. So radiation is all around us. From sunlight is the natural source of radiation. From sunlight to mobile signal, we find radiation all around us and has many application in our day-to-day life, including medicine, industry and technology. Understanding radiation is a key for safety and progress. So let us see. Electromagnetic radiation. Electromagnetic radiation is a form of energy that travel through space in the form of electromagnetic waves. Electromagnetic, the name itself says there is electric field as well as magnetic field, both are combined and they are perpendicular to each other in electromagnetic radiation. It includes types like radio waves, microwaves, infrared, visible light, UV rays, X-rays and gamma rays. You need to remember this in this manner only. First comes radio waves, then microwave, infrared, visible light, UV rays, X-rays and gamma rays. These waves have electric and magnetic field that oscillate perpendicular to each other and travel with the speed of light. And the speed of light is 3 into 10 to the power 8 meter per second. Now let us see the spectrum of electromagnetic spectrum. Electromagnetic radiation span a broad spectral ranging from low energy, long wavelength radio waves to high energy, short wavelength gamma radiation. So we will see one by one. This diagram shows the electromagnetic spectrum. Notice the changes in wavelength of the various form is given below, and the wavelength, it is in meters. You need to remember the value of each waves. Each wavelength you need to remember. First comes the radio wave. In the diagram, it is mentioned 10 to the power minus 3 meter. It is true, it is the boundary between radio wave and microwave. And the typical range of radio wave is 10 to the power minus 1 meter up to 10 to the power 5 or 10 to the power 6 meters. Then comes microwave, it is 10 to the power minus 2. After that, infrared, it is 10 to the power minus 5 meters. Visible range 10 to the power minus 6 meters. Ultraviolet rays 10 to the power minus 8 meters. X-rays 10 to the power minus 10 and gamma rays 10 to the power minus 12. Visible range in terms of Armstrong unit is 4,000 Armstrong to 7,000 Armstrong, that you need to remember, and the 7,000 Armstrong is given to red and blue end, it is 4,000 Armstrong. These values you need to remember and draw in your exam. Let us see each waves one by one. So starting with radio waves, electromagnetic spectrum breakdown we are going to see. Radio wave, its wavelength is you remember that value which I told you earlier, or remember like this, it is greater than 1 mm up to 100 of meters. Radio wave, it is the longest wavelength, low energy. It is used in broadcasting, FM and AM, mobile phones and Wi-Fi. And its sources of radio waves are broadcasting towers, mobile phones, Wi-Fi routers, etc. Now comes microwave. Microwave, its wavelength from 1 mm to 25 micrometer, and it is used for heat and cook food, used in microwave ovens, also used in satellite communication and radar technology. And its sources are microwave oven, satellite, radar system, etc. Infrared, its wavelength is from 25 micrometer to 750 nanometers. Infrared, we feel infrared as in the form of heat, used in thermal imaging, night vision and remote controls. And its sources are sun, warm object, thermal imaging cameras, etc. Visible light, Visible light, its wavelength from 750 nanometer, that is red end, to 400 nanometer, that is violet. Visible light, the only part we can see, used in lighting, display and optical communication, and source of visible light is sun. Ultraviolet or UV rays, wavelength from 400 nanometer to 1 nanometer. Ultraviolet causes sunburn, used in sterilization, water purification and detecting counterfeit money, and its sources are sun, UV lamp, welding arc, etc. X-rays, its wavelength range from 1 nanometer to 1 picometer. It is high energy, can pass through soft tissues, used in medical imaging, X-ray scans and security checks. Its sources are X-ray machine, medical and dental, cosmic sources, etc. The gamma rays, the wavelength shorter than 1 picometer or less than 10 to the power minus 12 meter. Gamma ray, it is the shortest wavelength, highest energy. It is having highest energy, used in cancer treatment, radiation therapy, sterilizing medical equipment and nuclear research. Sources of gamma ray are nuclear reactions, radioactive decay, cosmic sources. Thank you.